Alright guys, today we'll be going over section 8.5 or the law of sines. So this section is relatively short. In this section we'll be learning just about the law of sines. This law of sines states that for any triangle ABC, which we show here, let the lengths of the sides opposite the angles A, B, and C be the lowercase letters A, B, and C. Right, so we have angles A, B, and C. Across from angle A is side of length lowercase a. Across from angle B is a side of length lowercase b, and the same thing for C. So once we've defined the triangle in this way, what we can use the law of sines to say is that each the sine of each angle, the relation between the sine of each angle to the length of its opposite side is equal for all three angles and sides. So what this law of sines is saying is that you can take any triangle. Notice here any triangle. So far we've been using sine, cosine, and tangent for just right triangles, which is the only way that we've been applying, right? So everything so far in the chapter as far has been for only right triangles. But now we're learning about a law for any triangle. So it doesn't have to be a right triangle like this one that's shown here. So what this law is essentially saying is you can create a proportion using all the sides of the triangle and the angles. So you're creating a fraction between each angle and the side across from it, right? So the fraction sine of A over A. And that's saying that that is going to be equal to all the other fractions caused from putting the sine of an angle over its opposite side. So let's look at an example. So here we have a triangle with some limited information, right? We know that this side AC is 15, and we know the measure of these two angles. So we want to know what is the length of BC and AB. Well, first thing, going back to our law of sines, let's first just write out this equation, because we know that this is going to be true always, right? Even if we don't know some of these values, okay? So again, we'll start with side A, and we'll say that the sine of 48 over the side opposite of A, or BC in this example, is going to form this fraction that's going to be equal to the rest of the fractions, right? So that'll look like this. That'll look like this. So I just drew in the lowercase a just to maybe make it more clear for you guys. So again, we have our first relation in the law of sines, right? The sine of A is going to be equal to over the side opposite is going to be equal to the other relation. So now we'll work on the second one. So we'll just go to B. So we'll know again that that's going to be equal to the sine of angle B, which we know is 93 degrees, and over the length of the side across from it, or 15. Now our last relation will be the sine of angle C over the side across from it, which we also don't know. So we'll just call that lowercase c for now. Now you guys should be able to recognize that we can find angle C rather quickly, right? From knowing that these three angles have to add up to 180 degrees. So 180 minus 93 minus 48 is equals 39. So now we have written our law of sines. And we want to know the sine of BC, which we now have as A, and AB, which we now have as C. So to solve for A and C respectively, we're going to look at just two of our fractions at once. Okay? So for A, let's just look at the sine of 48 over A is equal to the sine of 93 over 15, right? So we're just going to look at these two for now. Okay. Well, that's just going to stay there. Okay, so just using these two inequalities, that the sine of 48 over A is equal to the sine of 93 over 15, we can cross multiply to get this equation right here, right? Cross multiply is, when you cross multiply fractions, you get sine of 45 times 15, which we have right here, is equal to A times the sine of 93, right? Hopefully we all know how to do that. And then simplifying to just solve for a, we get the fraction. This fraction right here, right? We just divided both sides by the sine of 93. So now we have the sine of 48 times 15 all over the sine of 93 is going to equal a. And if you put this into your calculator correctly, you should find that a is equal to 11.16 about. All right, so that's how we're going to solve for a. Now we can do the exact same thing with c, right? We can just use these two fractions of the equation and again cross multiply so you get this after you cross multiply. And again, you can rearrange the fraction like we did up here. Divide both sides by the sine 93. And again, if you type into your calculator correctly, you should get an answer about 9.45 as your final answer. All right, now we're going to go over a second example. What is the measure of angle S? I'm not going to do that. So again, we see here that this is not a right triangle. So we will be using the law of sines. So like we did in this example here, and like we learned at the beginning, we're going to first just create our three proportions, right? So let's start with S, right? So let's start off with angle S. So that means that the sine of angle S over the side across from it, or we already know is 11, is going to be equal to, let's just go with R, the sine of angle R, which we know to be 120, over the length of its opposite side, which is 18. And that's going to be equal to the sine of the last angle, angle T, over the length of its opposite side, which we don't know, so we'll just label as lowercase t. All right, so we're trying to find the measure of angle S, which is this value right here, right? The value of angle S. So again, we will use just two of these to kind of create a proportion. It should be obvious which one you choose, right? Because we want to choose the fraction that actually gives us real values, right? Like the sine of 120 is a real value and 18 is a real value. Whereas the sine of t, we don't know what that is equal to, and we don't know what lowercase t is. So if we used sine S over 11 and sine of t over t, we would have three unknowns, right? We would have three things that we didn't know. But if we use these two, then there's only one thing we don't know, and we can solve for it. So here you go. We'll be using these two equations. All right, so again, first step first, we are going to cross multiply. All right, so I typed out the letter S here because my S's were looking like 5s. So we have, when we cross multiply, the sine of S, this value of S that we're searching for, times 18 is equal to the sine of 120 times 11. So again, if we move everything over so we just have the sine of S on one side, we're going to get the sine of S is equal to sine of 120 times 11 over 18. Now, all of these are real values that we can use. You know, there's no unknowns here, so we can just put in different numbers we can just find this value, and if you do that correctly on your calculator, you get the value of about something that is close to 0.529. And that's, of course, equal to the sine of S. Now, hopefully by now, we've all learned that to go from this step to just solving for S, we have to, again, quote-unquote, divide by sine, which means dividing side by this side, but applying our inverse sine function to our value on the other side, the equal sign. And this will, again, if your calculators in degrees, incorrect. This will turn into S being equal to approximately 31.94. Alright, so this is basically the only thing we'll be learning in this section. I hope that you go back and look at these two examples when you are going to solve this question right here. So I will read the question, give you a couple of seconds to maybe pause the video, go back, rewatch it before you get to the actual question part. But this is question 1. We have a triangle with all 3 angles, one of the sides given, and we are asking what are the values of x and y. So we'll give you about 5 seconds now to pause it, go back, look at the other examples if you need to. But here is the only homework question for tonight, although there are 2 parts. Alright, so I will not be doing the solutions to the homework problems in the videos anymore. We will just be going over them in class the next day. So I'll see you all tomorrow.